we are given an inequality which involves a logarithm, which says that log of x minus 4 into x minus 3 to the base x plus 1 is less than 1. And we are required to find out how many integer values of x satisfy this given inequality. If you are given any logarithm, the argument of the logarithm has to be definitely positive. Similarly, the base of the logarithm also has to be positive and it cannot equal 1. So if you're looking at these conditions first before we look at the inequality, we want x minus 4 into x minus 3 to be definitely greater than 0. This would imply that either x has to be less than 3 or x has to be greater than 4. The next condition is that the base has to be positive. That is, x plus 1 has to be greater than 0 or x has to be greater than minus 1. And we want the base to be not equal to 1. So we don't want x plus 1 to be equal to 1 or x should not equal 0. If you're looking at these conditions first before we look at the inequality, what are all the possible integral values of x that it can take? X has to be greater than minus 1 and x cannot equal 0. So the smallest possible value of x is 1. The next smallest possible value is 2. It cannot be equal to 3 or 4 because it has to be less than 3 or greater than 4. So the next possible value is 5, then 6, then 7, 8, 9 and so on till infinity. This is the domain of x before we look at the inequality. Now if you're looking at the inequality, the base is x plus 1. For all of these values, x plus 1 is greater than 1 and this has to be less than 1. So we can simply expand the logarithm and remove it and it will become equal to x minus 4 into x minus 3 has to be less than x plus 1. If you are expanding this, this would imply that x square minus 7x plus 12 is less than x plus 1 or x square minus 8x plus 11 is less than 0. Now this is a quadratic equation which cannot be easily factorized. If you factorize this, you are going to get irrational numbers. So we can either factorize it, find the irrational numbers, find the range and then find out which of them are actually integers, or we can solve it in a easier manner. We'll complete a perfect square. As we have x square minus 8x, we'll add 5 to both sides. So the left hand side becomes equal to x square minus 8x plus 16. That is x minus 4 whole square. This is essentially equal to x square minus 8x plus 16 is less than 5. Or we want x minus 4 whole square to be less than 5. Amongst the numbers that we have seen, what are the values of x for which x minus 4 whole square is less than 5? When x is equal to 1, x minus 4 will be minus 3, its whole square will be 9. So 1 is not a solution. When x is equal to 2, x minus 4 whole square will be minus 2 whole square, which is 4. So this is a valid solution. When x is equal to 5, x minus 4 will be 1. So its whole square will be 1, which is less than 5. When x is equal to 6, x minus 4 is equal to 2. 2 whole square is 4. So this also is a valid solution. When x is equal to 7, x minus 4 will be 3. 3 whole square will be 9. So this is not a solution. Similarly, for all values of x which are greater than 7, clearly x minus 4 whole square will be greater than 5. So the only 3 integral values of the given inequality are 2, 5 and 6. So there are 3 such integral values. They are 2, 5 and 6.